All right. Welcome back to Why Math Why? A video series, as you hopefully well know by now, that is all about exploring the why behind math, as well as the how. So tonight, big time shout out to my Lower Makefield's a great place to live friends, some people that I've gotten to teach their students, their children, and just some all-around awesome community members. So big shout out to B Gnarly, Mr. Lingle, and of course, the amazing Georgia Tech engineer, Tony Kehoe. So this video is for you guys. This video is about the order of operations, and it came up as a discussion, really, and I'll kind of go over the problem that came up, and it was pitched on there, and this sometimes comes out the internet, where you've got these random problems, and it's kind of designed to torture you into wondering, do you know your order of operations or not? And I believe this was the problem. And so your order of operations, you know, everyone, not everyone, but a lot of people know or have been exposed to this mnemonic device, PEMDAS. And some sick math teacher somewhere along the line, probably with an Aunt Sally, came up with, please excuse my dear Aunt Sally, with order of operations. So the order of operations is a way to determine in what order you perform the operations of parentheses, exponents, so I'll just write that as like x to the fifth, multiplication, put a little dot for multiplication, or division, that's something that we often forget, addition or subtraction, that's an O, or subtraction, so plus or minus. And the reason why it's or is we're going left to right with these. So if multiplication comes first, we do multiplication first, between multiplication and division. If addition comes first, well, actually, if subtraction, let's say, comes first, then we do that first. So that's your old dear Aunt Sally. Now, how do we use it with a problem like this, and really, why is it used? So in this particular problem, you're going to do what comes in the grouping symbols, the parentheses, first. So that would be 2 plus 1. So we do 2 plus 1 first. Everything else gets copied. You're basically saying, I am a mindless copy machine. So that's 2 plus 1, I don't know what I just did there, is 3. That's the parentheses part. Now we look and we scan it and we see there are no exponents, so the next thing we go to is multiplication or division. So it's whichever one comes first, reading left to right. These are the rules that mathematicians years ago determined, and the history of this is no one knows who came up with these rules. There's not one single person attributed to it. I don't care who says that. There's many different people that say they've come up with this, but honestly, there is not one real person that's come up with it. Without it, math would not have a set way of solving equations, of going through simple and complex calculations that we do. So anyway, we look at this problem. Division, right here, comes first. So, before multiplication does. So we're on this level right now, so left to right. So 6 divided by 2, because really what this is 6 divided by 2, and I use dot notation for multiplication, times 3. 6 divided by 2 is 3. What remains is 3 times 3, and that answer is 9. Now, here's the thing about this, and you know, you can shut off the video at this point. This was a brief review of, please excuse my dear Aunt Sally, and the order of operations, and hopefully it was good for you. But I kind of want to go over another problem for those of you wondering why the order of operations might work the way it does. And this is totally my speculation. This is not fact. Again, no one knows who invented this or how it was invented. And so I'll basically do a random, sorry, that's water in the background of my awesome basement that you might be hearing in the background there. We've got a little pump. So this is high-class Hollywood stuff. Anyway, back onto the high-class production value. Looking at this, again, no one knows how it came up. I am just hypothesizing here. So if you take a look at, let's write all the same number. And let's look at expressions. So let's just use the number 2. And let's just do addition versus subtraction. Obviously, you're going to get different numbers here. You'll get 4 and you'll get 0. But my point being here is that the addition of 2 and the subtraction of 2, and, you know, maybe I'll go a little bit bigger than that. Let's go a little bigger. Let's go with 4 plus 4 and 4 minus 4. The addition of 4 is going to give you 8. The subtraction of 4 is going to give you 0. But the point is, you're not moving very much on the number line with those two. And my hypothesis is that the order of operations was designed to go with the most influential operations down to the least influential of the basic operations. And then the left to right is just because that is how we read things. Typically, not in all societies, I get that, but mathematically just kind of came along. But my big part is parentheses the most influential, and I'll show you that. Addition or subtraction, the same amount of influential. You're either bumping to the right 4 or bumping to the left 4. Okay, so with that said, now we go from there, we look at multiplication. So 4 times 4, or 4 divided by 4. All right, well, this operation, 4 times 4, is way more influential than pluses. In fact, how much more? 4 times more influential, because this is repeated addition of 4 times. This is division of 4 times. Way more influential in that you're chopping this into 4 pieces. Now I know you might be saying, yeah, but Groden, Matt, whatever you want to call me, dude that does math, 4 minus 4 equals 0. That's less than this is. So how is that not more influential than this? Well, look at any subtraction value. It doesn't have to be the same number. Let's say that I look at 1372 and I subtract 4 versus 1372 divided by 4. What's going to have the higher impact is the division. I mean, you're going to get way less, way quicker. It's repeated subtraction. And so that's why I think this goes to a different level of strength. Exponents go to an even higher level of strength than multiplication or division. And to look at that, well, let's just look at 4 to the 4th. If I raise 4 to the 4th versus multiplying 4 times 4, that's 256. Right? That is far and away more powerful than this is. And you might think, yeah, that's only going in one direction. Yeah, well, there are exponents that are called rational exponents, and we can do square roots with them. So let's say that I get like the number 400, and instead of dividing by, I don't know, 2, I raise it to the 1/2 power, which is taking the square root, and that's 20. Dividing by 2 would give you 200. Raising the 1/2 power gives you 20. So exponents, that much more powerful. And so, as I was discussing before, it's going from most powerful to least. So you might think, all right, parentheses, really? How powerful could parentheses be? Let me show you. Let's take a look at parentheses and the meaning it puts on a problem. So I'm going to do 5 plus 2 times 7. Okay, so if we put parentheses here first, this means that we have to do 5 plus 2 is 7, times 7 is 49. All right. Now this, let's see what the meaning of the problem, how it changes, how much it changes it. If I shift the parentheses over to a different part here, and I group all of this, and instead I do 5 plus 2 times 7, well, now I'm multiplying by, well, I'm just adding 5 instead of multiplying by 5 plus 2 and distributing the 7. 5 is no longer part of that. That's 5 plus 14 is 19. Those parentheses just change the problem drastically. Change the problem. I'm not talking magnitude that's only 30 apart. It completely changed the meaning of the problem. So again, my ideology with this, maybe not my ideology, my hypothesis is that we go from parentheses to exponents, to multiplication or division, addition or subtraction, due to the degree to which each of those operations can affect a problem. I think it's pretty cool, peeps. If you made it to the end of the video, wow. If not, then you're not hearing this. So anyway, I hope that you're still mathing hard. I really had fun delving into this with you all. Catch you on the flip side in the next one. Until then, like I said, keep mathing hard. See you in the next video. Peace.